Graphical method for vectors. So your basic idea of the graphical method is that you're using a scale. You're setting, for example, a certain number of centimeters to represent a certain number of meters, or a certain number of miles, or a certain number of kilometers, kind of like you would use a scale on a map. The tools that you're using then would be a protractor and a ruler, so you can draw a diagram to scale, and then you don't need to use any trig functions. You don't need to use Pythagorean theorem. Everything is done strictly by measurements. So then, example, suppose I tell you to walk 15 meters east and 25 meters north, and we want to find what the resultant is. Well, obviously a 15-meter line and a 25-meter line are not going to fit onto your paper, so then you can set a scale. Let's say 1 centimeter represents 5 meters. In that case, then we could set up a proportion. 1 centimeter is to 5 meters. We have a 15-meter line. How many centimeters would need to be represent that? And so that line would be 3 centimeters long. And I'm just going to write those values above. Similarly, the 25 centimeter line would be 5 centimeters long. And you solve down for those from proportions. So then we would draw a scale vector diagram. So I'm going to put my starting point. And then I'm going to use a ruler. My first value is east. So I need a line 3 centimeters to the east. So there is my line to the east, and that is a scale representation of 15 centimeters. Let's try that again. So there is my line, and I'm going to label it 15 meters. Now, the next line we need to draw is one that goes north. So we're going to take our ruler, we're going to rotate it, and head to tail, we're going to draw a 5 centimeter line in that north direction. Now, both of those lines were drawn to scale, and so then we can use a ruler and we can draw a resultant. From start to finish, we draw a line right there that is your resultant. Now, on your ruler, you can measure the length of that line. That line goes to about 5.9 centimeters. So then the actual length of this line is 5.9 centimeters. We can then use our scale to be able to calculate the actual value in meters. So 1 centimeter is 5 meters. We just measured a line to be 5.9 centimeters long. What's the actual length of that? And so then we solve that down. 5 times 5.9, and that's going to give us 29.5 meters. Now, our resultant is a vector, and a vector has both a magnitude and a direction. So then to measure the angle, our angle would be right here from our starting point. We're going to bring the protractor over. We're going to situate it right there at the starting point and measure that angle. Typically what I'll do is pretty much ignore the numbers on the protractor, and the actual plastic protractors are a little more precise than this one. I'll just count by 10. So starting at east, there's 10, 20, 30, 40, 50. I'm almost dead even, a little bit shy of 60 degrees. So I'm going to say that is 59 degrees and that would be north of east. And that is our resultant. By the same idea, if we look at another example, and I'm just going to keep the same values of walking. Actually, let me use a different value so we can use a different scale. You're going to walk 200 meters east, and then 350 meters at 30 degrees north of east, and we want to know what your resultant is. We're going to do the same thing. We're going to set a scale here. So I would probably go 1 centimeter represents maybe 50 meters. And so then 1 centimeter to 50 meters, I have 200 meters. So I want to know how many centimeters that's going to be. That'll end up being 4 centimeters. So using the proportion, this line would be 4 centimeters long, and then our other line would be 7 centimeters long. Now, we're going to need to draw it, so I'm going to give us a little bit of extra space here. And so I'm going to draw our starting point there, and the first thing we need is a 4 centimeter line to the east. So using the ruler, I need a 4 centimeter line. And now that represents our 200 meters. Now the next thing we need is a vector at a 30-degree angle, which means we're going to need to pull our protractor down. I'm going to put it right there. And now I'm going to mark out where 30 degrees is. 30 degrees from east, and east would be right along this direction. So 10, 20, 30 up from there. 30 degrees would be in this direction. Moving my protractor out of the way, the next line I'm going to draw is going to be in that direction, so I'm going to take my ruler over. Get it lined up. And then we want a 7 centimeter line in that direction. Right to there. So now that line represents our 350 meters. And the angle that we just measured of 30 degrees would actually be right in here. Our resultant then goes from start to finish. So I'm going to pull the ruler. I'm going to realign it. This is so much easier with a regular plastic ruler. And then we're going to draw our line, start to finish. That is the resultant. Reading off the ruler, looks like we're about a little over 10 and a half, looks like about 10.7 centimeters. So then I can pull my ruler out of the way and use our proportion. 1 centimeter to 50 meters. I just measured 10.7 centimeters. And then, so that's going to be a multiplying to solve down 50 times 10.7. And that gives us 535 meters. Now we need to measure the angle. So I'll pull the protractor back down to the starting point. And I'm measuring the angle right in here. which again, counting off by tens, there's 10, here's 20, so we're a little bit beyond 20 degrees. I'll say that is about 21 degrees, and that would be north of east. So notice there's no trig that I did in any part of this. It's just choosing a scale, using proportions, using a protractor and ruler to be able to draw these to scale, and then measuring the resultant. The one other vector operation is resolving a vector into components. Let me give us a little more space here. So if I want to resolve something into components, if I want to find the north and west components of 500 miles at 30 degrees, then what I'm going to do is I'm going to set my scale. I'll go 1 centimeter equals 100 miles. So then I'm going to need a 5 centimeter line. I'm going to draw my starting point. I'm going to pull my protractor down, and I'm going to measure that 30 degrees from west. So then 30 degrees would be right there. I'm going to go find my ruler. And now I'm going to take the ruler, rotate it, and I'm going to draw my vector in that direction. So I have it lined up so that 10 is right there on the origin. And so then I'm going to draw from 10 back to 5 centimeters. And that's my vector. And so this would be thank you for your patience. That would be my 500-mile line. What you're going to do, because I have a meeting I need to go to, is draw the line. And once you have the line, then you're going to draw the west side, draw the north side. You're going to measure this in centimeters. You're going to measure this line in centimeters. And then you're going to use your scale and convert those centimeters back into miles to get a number of miles west and a number of miles north. Okay, so it's a similar process, but you're finding two answers.